Hello Pythoneer, welcome to your 5th Python tutorials. Now, in the last video, I introduced you to Python data types. In this video, we are taking Python numeric types. So that's going to be our first data type that we'll be looking at. So, what is Python numeric type? So, numeric types in Python allows us to work with numbers. And we'll be looking at working with integer, we'll be looking at working with float, and then we'll also look at working with complex numbers. So first of all, let's start with integers. So what are integers? Integers in Python are 0, positive or negative whole numbers. Now this stems from our basic understanding of maths, our understanding of basic maths, okay, where we're basically working with numbers. Okay, so numbers allows us to do computations, perform all sort of operations, and then so on. Okay, so we have integers that are assigned either 0, positive or negative whole numbers, and then again they can also be binary, octal or hexadecimal numbers. Okay, so you are not going to only work with integers. You are not going to work with only whole numbers, but you'll be working with binaries, octal, and then hexadecimal numbers. And we are going to look at examples of how we use them in Python. So let's see an example from our code. Okay, so I'll switch to my PyCharm IDE. So if you do not know how to install PyCharm, okay, I'll leave the link in the description below to my video detailing how to download, install, and then set up the PyCharm IDE. But then again, if you are working with another IDE like Visual Studio Code, then come on, feel free, and then let's just get coding. Okay, so I have basically explained to you what integer data type is, okay, in Python. So let's see an example. So let's say I store my age. So age is equals to, let's say, 12. Okay, so yeah, just assume I'm 12 years. Okay, so age is equals to 12. Okay, so in Python, okay, anytime you create a variable, okay, and then you reference or you assign it to data, okay, in memory, okay, this data, as I explained in my previous video, will belong to a type. Okay, so once we create 12, okay, and then we create our variable and assign this variable to 12, okay, 12 is created in memory and 12 has to belong to a type. Okay, so now the way that we find out the type, okay, is to use this function called type. Okay, so this we'll be using in the rest of our tutorials, okay, and it's going to come in very handy. Now this is an inbuilt function in Python, okay, and we're going to talk about functions more, okay, in some other videos, okay, in the rest of our series. Okay, so just to find out the type, okay, so this type here is a function, okay, and it takes an argument. Okay, so the argument basically it's some data that you supply to a function. Okay, so a function, okay, like the type may request argument. So this argument here we are passing, okay, it's going to be our age variable. Okay, and then I want to output this. Okay, I want to output this compared to the default Python interpreter that will be used, that you use when that comes with your Windows. Okay, for an ID like PyCharm, you have to output it. Okay, so I'll output this. Okay, so the way you do that is to use the print, okay, the print function. Okay, so print here is also a function. Okay, so let me take the last bracket. Okay, so print into bracket what I want to print. So what am I printing? I'm printing the type of the age, okay, age variable. Okay, so like I said, age is pointing to 12. Okay, so even though we are passing age, what we actually reference and what we are referring to is 12 here. Okay, so I can run my code, okay, and then let's see the result that I get. Okay, so it tells me that age, okay, belongs to the integer, okay, class. Okay, and we can see that because age here is 12. Okay, so if we change this value, okay, to maybe 0, okay, and then we run, we are still going to get class of int. Okay, because this 0 here, it's a data type of int. It's a data type of int. So that is how we use that. Okay, so I can also say -1 and then I will still have a class of integer, because we said that integers are negative, zeros, negative, and then positive, whole numbers. Okay, so even 0 works. Now let's just say I write something like 0, 1. Okay, then as soon as I do that, Python throws an error. Okay, Python throws an error. Okay, so you cannot have leading zeros. Okay, so I can have just 0, and then I can have zeros that will throw the number. Okay, so this would, when I print this, it's still going to tell me it's class of int. Okay, and if I just want to print the age, okay, so I'll comment this out. I use the control / to do that. Okay, so I can just print age. Okay, print age, and then let's see what I get. Okay, so when I print age, okay, so you see that it tells me 0. Okay, because Python still sees this as 0. Okay, so what if I want to have something like a separator? Okay, so like let's say I'm dealing with figures. Let's say 1 million. Okay, so 6 zeros, 1 2 3 1 2 3. Okay, so when dealing with financial figures, okay, so sometimes you want to have like something like comments, okay, to separate your numbers. Okay, so something like this, you want to do this. Okay, but this is not allowed in Python. Okay, so running this, it's going to give me something different. Okay, so this is not the result that I want. Okay, this is not the result that I want. Okay, what if I use dots? So if I use dots, Python is not going to treat this as an integer. Okay, so the only way I can have separators, okay, is to use underscores, and Python would recognize that as a delimiter. Okay, so you can use this underscore to delimit. Okay, so to kind of like separate your values, and then when I print it, it's going to print 1 million. Okay, 1 million. Okay, so like I said, you cannot have decimals. Okay, once you have decimals, okay, it's going to lead you into a different data type. Okay, which we are going to talk about now. Before I move on to the different data type, the next data type, which is float. Okay, I also want you to know that, okay, you can have as many, okay, as many, I mean, you can have as many, like integer characters. Okay, and this is not limited. Okay, the only limitation has to do with your computer memory, how much your computer can allow. If not, I can just print this, and then when I run this, okay, and then I am going to have my results, okay, separated. So okay, you don't have to be limited. Your only limitation has to do with your the size, okay, I mean the memory on your computer. Okay, so the last thing that I'll talk about is the fact that though I may have something like this, which is not, okay, an integer, okay, it's a type of float, which we'll talk about next. Okay, but there's a way that I can convert this, okay, into an integer type, so that I get rid of the extra, I mean, decimal values. So the way we do that is using the int. So here, this int here as a function, okay, and then I'll pass the data that I want to to convert. Okay, so when I run this, okay, and it's going to print 1. So this is using, okay, I mean a concept called casting. Okay, so even though I have my data in one format, I still want to go ahead and then convert it, okay, or to force it to be an integer. But just know that this will not always apply, okay, in every scenario or principle. Okay, so sometimes you cannot convert from one particular data type to another data type. Okay guys, so that has to do with integer, okay, for you. Yeah, okay, so let me not forget one more thing. Okay, so integers doesn't only has to do with numbers, like I said. I mean, negative, 0, negative, and positive whole numbers. Okay, you can also work with binary, octal, and then hexadecimal numbers. Okay, so if from your math foundation, okay, basically we've been dealing with, okay, we've been dealing with decimal numbers, that is 1 to 9. Okay, so 1 to 9. Okay, so 1 to 9. So that means we're able to count. Okay, we're able to count from so we're able to count from 0, okay, 0 to 9. Okay, so making 10 digits. So we are saying so we are able to count from 0 to 9. Okay, so that means we are dealing with decimal numbers. Okay, but then we can also have other types, okay, which is the binary, that allows us to work with base 2. Okay, so 2 bases, so it's just 0 and then 1. Okay, so Python understands working with this kind of data type. Okay, so for instance, if I have, let's say, 25, okay, so x is equals to 25. Okay, so I can convert this, okay, to a binary number. Okay, so the way I do that is saying binary. Okay, so this binary here is a function and it will take the number that I want to convert. Okay, so if I print this, okay, if I print this, then Python is going to give me the number in binary. Okay, so binary numbers basically consists of ones and then zeros, and then there's a way that we calculate binary numbers. Okay, I'm not going to do that, okay, but you can check it out. I'm not going to do that, okay, but you can check out the formula, okay, on the internet. Okay, so basically this is the number that we are dealing with. Okay, so this 11001. Okay, so that is our binary number. Now this 0, okay, b, okay, it's a way that we use to represent binary numbers. Okay, so without this 0 and then b, binary, okay, Python will treat this as, I mean, an integer number. Okay, so for instance, we can have our numbers, okay, our binary number, and then we can print the result. So for instance, I can print, okay, so I can print 0 b, okay, then 1, so 0 b means for binary, so 1 0 0 0 and then 1 1. Okay, and I think this is supposed to give me 35. Okay, so let's say if this, good, so you see that it gives me 35. Okay, so I can do that. Okay, so I can also work with, I mean, octal numbers. Okay, so for 35, the octal value, okay, will be this. So it's 0 and then O for octal. Okay, so 0 and then O for octal, and then 4 3. Okay, so octal values, okay, are also in base of in 8. Okay, so you can count up to 8 digits. Okay, so I think 0 to 7. Yeah, 0 to 7. Okay, so I can run this and then it should give me 35. Okay, and then finally I can also work with hexadecimal values, which is 16. Okay, so you can have it's 0x, okay, for hexadecimal values, 0x, and then I can say 23. Okay, so that should also give me 35. Okay, good. So guys, that is that for integer numbers. So let's talk about floats. Okay, so basically floating numbers or floats, okay, are real numbers with fractional parts. So something like 123.677543 is a float number. Okay, and then this can also be denoted by a scientific notation, E, okay, capital E or small e, and then we'll see that in action. So let's see that in action, okay, in our code. Okay, so now previously we looked at integers. Okay, so let's say I want to let's say store the value of let's say acceleration due to gravity. Okay, so I have gravity, okay, and then I'll have gravity is equals to 9.8. okay, so when you have a whole number that has a decimal part or a fraction part, okay, that number becomes a float. Okay, so I can check the type. Okay, so I can print the type, and so the type of the number, so I'm sure you understand type. Okay, so type allows us to get to know the class that this particular object, which is gravity, belongs to. So type, and then I'll say gravity. Okay, and then I can run it, and then Python should tell me that it's a float. Okay, so I can also have, so I can have so many numbers. Now, just like integer, okay, float, okay, you can have as many precision values as you want. Okay, you can have as many precision values as you want, and then it's not limited. The only limitation will have to do with your computer. Okay, so you can have that. Okay, so I also told you that you can represent very large values, okay, in scientific notations. Okay, so let's say I have population. Okay, so I have population, okay, to be 30 million. Okay, so I told you that you can denote, okay, you can have separated values, so 30 million. Okay, so you can do this just for, I mean, readability sake. Okay, so when I print population, so when I print population, okay, and then I run, okay, so I should get 30 million. Okay, so let's just say this is a large number, okay, and then we want to represent it with scientific notation. Okay, so I can, first of all, I can do this. So I can just say population, again it's, okay, so I can say 30, okay, so something like 30 times 10, okay, exponent, let's say, so 6. Okay, so where's this 6? Okay, so basically what you are saying is that you have so this 10, okay, so 10, so you are just saying 10 times 10 times 10 times 10. Okay, so like 10 multiplied by 8, so like 6 times. Okay, so something like this. Okay, so 10, okay, by 10, okay, so by 10. Okay, so this is what you are trying to represent over here. Okay, and that should give you 30 million. Okay, so if I run, okay, so let me just get this rid of this. Okay, so I have to, if I print population. Okay, so from our previous videos I told you that you can reassign, okay, we can reassign values, okay, or data to variables, and that's what I have done over here. So when I run, okay, it's going to print this. Okay, so you can denote this by scientific notation. Okay, and the way you can do this is by using e. Okay, so I can just say, instead of 10 raised to the power exponent 6, I can just say 30, okay, e6, okay, 30 e6, okay, and so 30 e6, okay, and then when I run, okay, so when I print, okay, it should give you 30 million. But notice that the output is always going to be a floating. Okay, so you can either use this or I can use that, and then it's supposed to give me the same thing. Okay, so that's that for floating. Okay, for floating numbers. Now finally, under integer, let us look at complex numbers. So the complex number is it's actually an imaginary number. Okay, so it's a complex number as the name sounds, and a complex number has two parts. Okay, so it has the real number and then it has the imaginary number. So the real component and then the imaginary component. So for instance, 2 plus 3j. Okay, so this 2 here is the real number, which you can you can determine this value, but the imaginary component or part is the 3j. Why is it imaginary? Because this j here, okay, it's a number that is just imaginary. It's not known to the reader. It's not known. Okay, so that is why it's imaginary. So this multiplied by that will give you that imaginary component, and then this is how you represent it. Mind you, you cannot use any other there's a letter, okay, alphabet apart from the j. Okay, so I was just wondering why they didn't do like 2 plus 3i, but you have to use the j. Okay, so this represents the imaginary. Now this is complex, okay, but as you advance further, you just know that you can, there's a way that you can solve these complex numbers. So let's finally look, switch to our editor, okay, and just look at an example. So for instance, I can have x, okay, is equals to 3 plus, let's say 6, and then j. Okay, so j as in small j, okay, and then so it's x. Okay, so I can print okay, sorry, I think good. So I told you that indentation is very important in Python. Okay, so if you do not indent your code very well like this, okay, you're going to have issues. Okay, so I can print, okay, I can print the type of x, okay, and then let's run, and then it should give me a complex. Okay, it should give me a complex. Okay, so let's say I want to replace j with I, and then let's run, and Python is going to throw an error. So this is a rule in Python when representing complex numbers. Okay, so guys, in the next video we are going to look at text data type. Okay, so thank you for being part of the video, and then hope you learned a lot. See you in the next video.